Have you ever wondered why these are the permutation and combination formulas? What's actually happening here? Let's find out. Welcome to Howie's Hypothetical Ice Cream Shop, where we have 10 different flavors. And for today's special, you can choose 3 different flavors and have them in either a permutation cone or a combination bowl. Now, I wonder, how many different permutation cones and combination bowls are possible? First, what's the difference? Well, in a permutation cone, order matters. If you tell me vanilla chocolate strawberry, that's a different experience than saying strawberry chocolate vanilla. Whereas in a combination bowl, order doesn't matter. Whether you tell me vanilla chocolate strawberry or chocolate strawberry vanilla, I'm going to give you the same thing. Now, let's talk about the permutation cone. Because we have to choose 3 different flavors, there would be 10 options for the first scoop, 9 options for the second scoop, and then 8 options for the third scoop. And then we would multiply them to get the answer. But why do we multiply? Well, we could think of this as groups of groups. So if I completed this tree, we would have 10 groups of 9 groups of 8, or 720 different permutation cones. So if we have 10 flavors and have to choose 3 different flavors, we would have 10 times 9 times 8 different permutation cones we can make. Now, this looks like the beginning of 10 factorial. So how can I write 10 factorial in a way that I just have the first 3 numbers? Well, we can divide 10 factorial by 7 factorial, because all of these would simplify to 1, leaving 10 times 9 times 8. Now, let's write 7 as a relation between 10 and 3. And 7 equals 10 minus 3, so we can rewrite it like this. And when we generalize this, we get the permutation formula. So we start with n factorial, and r tells us how much of n factorial we need. Now, let's talk about the combination bowls. There are still 10 times 9 times 8 different ways of telling me 3 different flavors, but there are a lot of duplicates. Every group of 6 is now going to count as one way, because all of these are the same in a combination bowl. Whether you tell me vanilla chocolate strawberry or strawberry chocolate vanilla, I'm going to give you the same thing. Now, because every group of 6 counts as 1, we would divide by 6 to get the answer, and we could think of 6 as 3 factorial. 3 times 2 times 1. Because if you were to name 3 flavors, there are 3 options for what to say first, 2 options for what you say second, 1 option for what you say third. 3 times 2 times 1. Now, we can rewrite 10 choose 3 like this. We see the permutation right here, and we're dividing it by 3 factorial, because every group of 6, or 3 factorial, now counts as 1. So when we generalize this, we see that the combination formula includes the permutation formula, but we're just dividing it by r factorial because there are duplicates. Every group of r factorial now counts as 1. That's why we divide. And though that form may paint a clearer picture of what's happening, the combination formula is more commonly seen like this. So there you have it. That is how we can derive the permutation and combination formulas and how to make sense of what's happening here. Hope this helps.